Okay, so let's start. Is Janet able to join the Zoom lesson right now?
Let me ask them.
Yeah, can you help? Yeah, thank you.
No, it's very dependent from you.
Next week, what is new? What is new?
Same model, everything except that.
It's not so
Forty.
many. First of all, make it
40.
rollbacks.
Okay, great. Yeah, you can maybe help this log in detail to Janet so she can join. And if you couldn't, there's still a video, okay, to fall back to.
Fire.
Is that fire or ember?
Yeah, fire.
I
Right,
can
so
distinguish the
it's 667 306.
Same as this.
Same as yesterday. 667 306 2184. Passcode is here and right.
Yes.
Okay.
What of the dog?
So let's pick up from where we left yesterday. Okay, so we said transition metals, okay, they are stronger. Okay, they are by stronger, I mean they are harder, they have higher melting point. That's because they have more delocalized electrons. And having more delocalized electrons means they have stronger metallic bond than the main group metal counterpart. So this will have weaker metallic bond. So after all, you remember that metallic bond strength is proportional to the number of delocalized electrons, right? So number of delocalized electrons. So this is why transition metals, they are more useful in everyday life. For example, in the making of like the car body, the doorknob. Okay, see, we don't want to use main group metals. Okay, in this application because they are very soft. You don't want the car to deform that easily. Okay, if you're the passenger inside the car. So metals like transition metals, they are very important in life. Okay, so because of their air strength, you can write down. So because of their air strength, so if she couldn't join in, let me open the app on the side so we can see if she's joining. Okay, so right, and here we have I put this down because of their air strength. They are very important in life. Okay, so they are important in life. For example, we have iron can be used to make car body or doorknob. And then metals like zinc, okay, they are used to make coins. You don't want to make coins out of main group metal because they are too soft. Okay, as a legal currency, it has to be durable. It has to be not able to deform easily. So this is why transition metals, they are very important. The first property. The second property of right. Yeah, is she able to?
She's not responding.
Okay, yeah, so we'll check if there's a pop-up here, okay? So the second property that I want you all to pay attention to is the variable oxidation state. So why can transition metal exhibit variable oxidation state when the main group metals cannot? Well, that's because main group metals, remember I used the color blue for main group metal and orange for transition metal. Main group metals, they can only lose a fixed number of electrons. Okay, so can only lose their outer mole shell electron. So outer mole shell electron. There's only one outer mole shell. Okay, but then transition metals, they can lose not just the outer mole shell, but the second shell before the outer mole shell. So you have transition metal, they can lose both the outermost shell electrons and the electron in the second last shell. Right, so they can lose both the outermost shell electron and those in the second last shell. Right, if we go back to scandium and titanium, scandium and calcium, okay, our examples here, you see that calcium can only lose 2 electrons because there are only 2 electrons in the outermost shell, so this is the outermost shell. Transition metals like scandium, okay, it can lose both the outermost shell electrons in here and also the electrons in the second last shell. Okay, this results in variable oxidation state. Okay, so you have calcium in here. So this is calcium, this is scandium. So calcium will only show +2 oxidation state because it can only lose 2 electrons. It cannot lose like more than 2 electrons. So it will only show +2 oxidation state in calcium 2+. Scandium, it can show, because it can lose more than 2 electrons, as you can see. There are how many electrons in total here? 11. Okay, so that means it can have the like additional electrons to lose. So scandium can show +2. Oh, I see her now. Right.
Join.
Hi,
Janet.
Right.
Janet.
Hello, hello, hello.
Janet.
Can you hear us from there? I don't know. Okay. Oh, I think it's because it's connected to the monitor. Okay, so maybe Jeanette, you can maybe type out your response because it's connected to the monitor and maybe the monitor has no sound. Okay. So if you have some questions, Jeanette, you can raise it in the chat. Okay. And right. So okay, we'll do this side by side. Just type out your questions. Okay, if you have some. So scandium can show +2 or +3 oxidation state because it can lose not just the outermost shell electrons, but also some of the electrons in the second last shell. For this reason, scandium can show 2+ or even 3+ oxidation state. Okay? So some transition metals, they can show even higher oxidation state. For example, permanganate. Do you all remember learning about permanganate or maybe dichromate in organic chemistry? What are these agents? Oxidizing agents. Okay, so they are oxidizing agents. So on the next page, I want you to put down some examples of these oxidizing agents with transition metal. Okay, so you have MnO4- and Cr2O7 2-. Can you tell me what is the oxidation state or the oxidation number of the underlying transition metals?
-7.
Mn is not -7, but
+7.
+7. Yeah, +7. Okay, when asked to state the oxidation number, you don't just include a number, you need to include a sign. Okay, so it's +7. So can you put down transition metals in oxidizing agents? Okay. And then we'll look at transition metal that are reducing agents. Okay. The first ion here, if you remember the name, is permanganate ion. Okay, so permanganate ion, where Mn has the oxidation number equals +7. If you don't remember how this number is obtained, okay, you can refer to this calculation. Let X be the oxidation number of Mn. And because we have 4 oxygen, each oxygen is worthy of what? What is the oxidation number of oxygen?
-2.
-2 in compounds and in ions. And because there are 4 of them, they add up to -1. Okay, so they always add up to the total charge of the ion. So before I tell you the answer to dichromate, okay, I want you all to work on it. If you know the answer, don't yell out the answer. Give other students a chance to work this out. Can you figure out the oxidation number of each chromium? I repeat, each chromium, not 2 chromium, but a single chromium. Help me solve this equation. Set up an equation first while I write down the name of this ion. So So this is dichromate ion. And I need you to figure out the oxidation number of one single Cr. Okay? We'll check the answer in 20 seconds. Right, yeah, Janet, you can also work on this, okay, and you can maybe type out your answer. Right. So, anyone got the answer? 6 plus 6. Don't forget the plus sign, okay, so it's plus 6. So you have x times 2, so there are 2 of them. And then you add it to -2 times 7, which add up to -2. So x is plus 6. Don't forget the sign, okay, plus 6. So we have dichromate ion and permanganate ion. When you see a very, very high oxidation number, well, admittedly, these are really high oxidation number. It indicates that they are covalent. So can you put down high oxidation number, like plus 6 or plus 7, means these structures are covalent. Okay? Let me draw it out, and then you will know why they are covalent. Okay? You don't have to memorize the drawing, but you may be asked to use the drawing to explain why Mn has an oxidation number of 7. So this is MnO4 minus, and then this is Cl2O7 2 minus. Okay, so Cl 1, 2, 3, 4, 5, 6. Okay, like that. So this is Cl2O7 2 minus. Can you tell me if they obey or violate octet rule based on the structural formula? Do these species, MnO4 minus and Cl2O7 2 minus, obey or do they violate octet rule?
Violate.
Violate. Can you tell me which atom here is violating octet rule?
Mn.
Mn.
Cr.
Cr, yes. Okay. How many electrons do you see around Mn right now?
7.
Like 2, 4, 6, 8, 10, 12, 14. 14. Okay. If you consider just the electrons from Mn, yes, 7. Yeah, but you know when you share electrons, your partner will also contribute to the remaining half, right? So this is why I counted double. So there are 2 electrons here. One from Mn, one from O, okay? But as you can see here, Mn violates octet rule, okay? So does chromium, okay? So these are the expanded octet species. And you can see that they are covalent because of the covalent bond. Okay, you see these lines are covalent bond. Okay, so they are expanded octet structures. What about lower oxidation states? Mn and Cl2O7 2 minus, okay, the 2 metal, manganese and chromium, they can also exist in lower oxidation number. So when MnO4 minus acts as oxidizing agent, do you remember what they will become? When you oxidize others, what will you become? You will become reduced. Okay. In the case of MnO4 minus, it becomes Mn2 plus. What about Cl2O7 2 minus? Cl3 plus. Okay. So put down this very important note. As these oxidizing agents oxidize other chemicals, so oxidize other chemicals, they become reduced. They themselves, okay, become reduced. So they themselves become reduced. And the oxidation number wanes down in this process, okay, indicating that this is reduction. So this is reduction because the oxidation number went down from +7 to what in Mn? 2 plus 2 plus 2, yes, okay. Went down from +7 to +2. Note the difference between charge and oxidation number. When you say 2 plus, you're talking about the charge. Okay, of course this is 2 plus here. So when asked to state the oxidation number, the sign comes first. Okay, sign comes first. So this is +3. So there's a slight difference between charge and oxidation number. Okay, so write this down. The charge is 2 plus, but the oxidation number is plus 2. So when you describe the oxidation number, the sign comes first. Okay, so sign comes first. When you describe the charge, the number comes first. Is that clear? Okay, they are not at all the same. Because when you describe MnO4 minus, the charge is -1, right? The charge is -1 for MnO4 minus. But the oxidation number of Mn is +7. So this is to say that charge and oxidation number, they are not always the same thing. They're not always the same thing. Okay? Right. So we have MnO4 minus becoming Mn2 plus. Okay? And then we should look at the next part. Any question about the MnO4 minus and the Cl2O7 minus? Okay. So on the opposite side, we look at some other agents. Okay. Transition metals. So transition metal species in low oxidation states, they are reducing agents. Okay, so in low oxidation states are reducing agent. Okay, I'll explain, don't worry. Copy this first. What are some examples of transition metal species in low oxidation state? Okay, like iron 2 plus. Okay, so write down iron 2 plus. So this is I'll use this as an example later. They are like a reducing agent. And then transition metal species in high oxidation states, like the one you saw, MnO4 minus, Cl2O7 minus, they are oxidizing agents. Okay, there are two oxidizing agents that you must know right now. It's MnO4 minus, Cl2O7 minus. Let's check if they are indeed having a high oxidation state. This is +2. Fe is +2 in Fe2 plus. Mn is +7 and Cl is +6. Why is it that species in low oxidation state, they are reducing agents? Because you know, if your oxidation number is low, okay, it means you have a potential to go to a higher oxidation state. So can you put down Fe, like what are some oxidation number possible with Fe? So this is oxidation number of Fe. It can go from 2 plus to 3 plus. And for MnO4 minus, it can go from MnO4 minus to Mn2 plus. For Cl2O7 minus, okay, it can go between Cl2O7 minus and 3 plus. So if you have to act as a reducing agent, it means you have to be oxidized. Do you remember that a reducing agent will undergo oxidation? So let me write down this summary sentence below first, and you should copy this. A or an reducing agent compared to an oxidizing agent, what will happen to them? So a or an reducing or oxidizing agent will undergo, what is the reaction that reducing agents will undergo themselves? Oxidation, right? So a reducing agent will undergo oxidation, and an oxidizing agent will undergo reduction. So for something to be a reducing agent, it has to have the potential to oxidize. Okay, can you see that in here? Look at Fe2 plus. The only way for the oxidation number of Fe2 plus to change is it to go up or to go down? Is to go up, meaning it can only undergo oxidation. So for things that undergo oxidation, what must they be? Reducing agent. So this is why Fe2 plus is the reducing agent, because the only way that the Fe2 plus can go is up. Okay, the oxidation number can only go up. Okay, so we say because Fe2 plus can be oxidized to Fe3 plus, so to Fe3 plus, therefore we say Fe2 plus is reducing agent. We are using this part of the summary here. Something that will undergo oxidation is a reducing agent. What about MnO4 minus and Cl2O7 minus? Okay, look at that. The only way they can go is up or down.
Down.
Down, meaning they can only undergo reduction. And according to this summary here, things that can undergo reduction, they must be oxidizing agents. Yes, okay, so maybe you can use another color here. So the only way is down for these two species. They cannot go any higher than that. +7 is the max, okay, for them. They cannot go up anymore. But this one, so you can write down this can undergo oxidation. It's a very tricky concept, but I think maybe this summary would help explain it better. Yes?
Do we have any +9, +10 oxidation
Uh,
number?
Unlikely, because to form a high oxidation number than +6 or +7 means you need to form more than 7 covalent bonds.
Oh.
Yeah, it's very rare that you see a species with more than 7 covalent bonds. MnO4- is already, one of the most extreme examples. So yeah, nice question, but no, okay. Yeah, so we have, unfortunately we are not done with the transition metal species. How do you show that Fe2 plus is a reducing agent? Okay, so to show, write down, to show that Fe2 plus is a reducing agent, okay, we can react it with chlorine. Okay, so we can react it with chlorine. So can you complete this equation? If Fe2 plus is a reducing agent, can you tell me what will happen in here?
3
Yes, okay. First of all, you need to ask yourself, if this is a reducing agent, write down point 1 first. This is a reducing agent. So it will do two things. Number one, it will reduce the other partner here.
That's good. I did.
Okay, so this is number 2.
Learn about the
Fe2 plus will reduce
And that'll be.
Cl2 to what is something that has a lower oxidation number than
Zero?
0 in Cl2.
-1.
Chloride ion, right? So Cl minus, so you can put down Cl minus. The second thing that it will do is it will do something to itself. It will be oxidized. Okay, yeah. So write down these points. Okay, in exam they will just give you the reactants and expect you to fill out the rest. Okay, to show that iron 2 plus is a reducing agent, we can add chlorine to it. Okay, for example, so you will then get Fe3 plus. Okay, so this is how you complete the equation here. And of course, if you want to balance it, yes, how do you balance it?
2Cl.
Yeah, you can either balance it in this state or you can balance it using the trick I taught you. Split this into two half equations first, like this. Write Fe2 plus becomes Fe3 plus first. Then you write Cl2 becomes Cl minus. And then you balance these two equations separately. How do you balance the top equation? Add to which side? To the right side. Remember, always add electron to the more positive side, which is the right hand side. What about the second equation? We add a 2 here first, and then we add
2 electrons.
to the left. Yeah, I will recommend you balance it this way, rather than balancing right in this equation. So split into two half equation first, and then you balance the ox and the red equation separately, and then you add them up. Okay, well, you know you can't add them up directly. You have to multiply the first one by 2 before you add them up. And finally, you have your overall. What is the overall equation? After you multiply the top equation by 2 and you add 2 Fe2 plus Cl2, 1 Cl2 will do, giving 2 Fe3 plus. So if you are forgetful, do this. Okay, draw an arrow here. That way you will not forget that there's also a 2 here. Do you see what I'm saying? Okay, I know it could be that you are not forgetful, but you just somehow don't remember it in the exam. So you have 2 Cl minus. So you see, this is a much safer approach to balance the equation than to directly balance, just by looking at this. Because when you look at this, you may be distracted by the charges. You might not be able to think straight when you try to balance straight from this equation. So split it into two equations before you balance it. Okay? Then, now, to show that MnO4 minus and Cr2O7 2 minus, they are oxidizing agents, we can react it with a reducing agent. Okay, so a very common reducing agent will be, SO2. Okay, like SO2. Right. And any question? No. So on the next page, we look at something that you haven't seen before. Okay, in the organic chem chapter. It is that KMnO4 can also be used in alkaline condition. Okay, so KMnO4 in acidic and alkaline condition. Okay, so this has a connection to the organic chem chapter. So let me check if you have done revision. Which reaction in organic chemistry did we talk about involves KMnO4 as a reactant? Addition of alkene with, well, it's not actually an addition reaction,
Reflux.
but this is an oxidation reaction. Yeah, being like an oxidation reaction. Okay, redox, the ox means oxidation reaction. It is this reaction, do you remember? When you react alkene with a sister bond with the oxidizing agent, okay, so this is contributed by KMnO4. So by KMnO4, the oxidizing agent. It will combine with the O and H2O to form, do you remember what we call this class of product? Can you tell me what I can put below the two carbon? Two OH group. Two OH group. Can you see that these two things, the O inside the square bracket and the H2O combines to give two OH group, right? Yeah, okay, so therefore these two OH group, they will split themselves across the CC double bond. So I will argue that this is not just an addition reaction. This is more like an oxidation reaction because there's a gain of oxygen in the process. So this reaction is the oxidation of alkene. So oxidation of alkene into diol. So this is an alkene here. Yeah, undoubtedly this is an alkene because it has a C double bond. And this is a diol on the right because it has two OH group. Okay, so this is how you turn an alkene into diol. What do you need to remember? It is that the KMnO4 in this equation has to be in alkaline conditions. Okay, so can you circle this part and write down? The KMnO4 used in this reaction, okay, is KMnO4 slash OH minus, meaning it is in alkaline condition. Okay, why? That's because alcohol. Do you remember the oxidation pathway of alcohol? What can primary alcohol be terminally oxidized to?
Aldehyde, aldehyde.
That's not terminal, but terminally carboxylic acid, right? Yeah. If you use acidified KMnO4, let me tell you, you will not get diol because the alcohol will just keep going. It will just become carboxylic acid instead. So, can you write down the reason? The KMnO4 used is KMnO4 slash OH minus. Okay, so the explanation is that, KMnO4 acidified is a stronger oxidizing agent than KMnO4 in the alkaline condition. If you use the too strong oxidizing agent in this reaction, it will not stop at diol. It will become dioic acid or dicarboxylic acid. So write down, this is the strength of oxidizing agent in this order. Okay, so you see this is a stronger oxidizing agent than KMnO4 in the alkaline condition. This is a weaker oxidizing agent. What happens if you incorrectly use KMnO4 slash H plus? Okay, let me show you an example. If I have this guy here, this is ethene. It's actually ethene. I want you to name the products now. if I use KMNO4 slash OH minus, can you name the product for me? In fact, we drew the same product on top, you just have to name it. When I add the OH group here, what would this product be called? What do you call a product with 2 OH group and 2 carbon? What is the root for 2 carbon? Ethane 1,2-diol. Ethane 1,2-diol, correct. Let me show you what happens if you use KMNO4, what is that? Acidified, yeah. So if you use KMNO4 slash H plus, okay, we will start with ethene as well, okay. But then instead of forming ethane 1,2-diol as your final product, because KMNO4 is too strong in the acidic condition, it will oxidize both of the OH group. Before I tell you the answer, can you tell me what is the class of each alcohol group? There are 3 classes of alcohol: primary, secondary, and tertiary.
Yeah.
When you look at ethane 1,2-diol, focus on this carbon here. Is it primary, secondary, or tertiary? Primary. Each of the OH group here is primary. Can you write this down? Okay.
Oh, it's
So
only connected
each
to one carbon.
of the OH group is primary.
Primary group is
And you remember that primary alcohol can be oxidized first to aldehyde gas and then to carboxylic acid. So recall that primary alcohol can be terminally, okay, ultimately oxidized to RCOOH, carboxylic acid. So this is the resultant product. Can you draw me the product? Because I want to check if you know. Yeah, and you can draw as well. So try to draw the product.
It's connected to one group. It's connected to one C.
So here's a recap. When you have ROHHH, what is the first thing that we do when we oxidize a primary alcohol? What do we take out? We take out 2 H's. The 2 H's come from here. So we will have, you see you remove 2 H's. You then have RC, don't forget to change it into a double bond, right? What is the second thing that we do? We add an oxygen, yes. Okay, so where do we add the oxygen to?
Between C and H.
Yes, between the C and the H, right? So you have RCOOH. Now we just have to do the same, okay? It's just that we have a slightly weird looking alcohol here. So we will first remove 2 H's, and you need to do it twice. Because you have 2 OH groups, so you remove this and that, remove this and that. So you will have something that, can you complete these steps on the right? I don't want you to just give you the answer. I want you to try, okay? So can you observe the pattern? Complete the equation here. Okay, it's about finding pattern. Okay, so make sure that you also try it. Okay. And you should name the product because we have talked about how to name things with 2 OH group, things with 2 COOH group as well. Okay? Yes. But keep the answer to yourself first. Okay, that's just a suffix. Okay? Keep the answer to yourself. We will check the answer later. In 10 seconds. Okay, time's up. Okay, so it's C double bond OH, C double bond OH. Okay, and then you will have to add O twice. Okay, so twice. So your final product would be H O C double bond O. So C double bond O, C double bond O, O H. So what do you call this? Not just the suffix, but I need the full name.
Ethane diol. No
Ethane
acid.
dioic acid, yes. Ethane dioic acid. Okay?
What about the aldehyde one? How can you?
What about ethane diol? This is. So ethane diol.
No
Yeah,
need
like-
number?
No, because aldehyde, just like carboxylic acid, I'm glad you asked, they must be at the end.
Okay.
There's no need to indicate that, okay? It's redundant, okay? So, yeah, that's it. So you can finally draw the product, okay? So draw the product. So it is ethane dioic acid. So this product here, unless this is the one you want, yeah, you will not get ethane one 2 diols, okay? You will have ethane dioic acid. Is that clear?
Yeah.
Okay? So mind the difference between acidic and alkaline condition KMNO4. Okay? Right, so we'll wrap up the chapter next time, so we are done with this, and a bit of this. Okay, actually a bit of this. Okay, we have
A bit.
color iron.
You
Yes.
can draw half.
Yes. Yes. What's the question?
No, like you can draw the circle half.
Oh.
Halfway.
Yeah, we are halfway. Yeah, we are more than halfway. Okay. So,
Then
can you try the questions I uploaded onto Google Classroom? Yeah. Or you can download it, right? Because some students told me that they saw the word unsupported file icon D. Yeah, you just click the three dots. Yeah, it's normal. If you see unsupported file, like you need to click the three dots right here. Then you click